Welcome to my second video illustrating some simulations using Excel. So let's read number 1. Joe has 6 hours to complete all of his work for Quan 1000. Based on past work, he estimates his homework will take on average 3 hours with a standard deviation of 0.3 hours. His test will take on average 2.5 hours with a standard deviation of 0.5 hours, and we'll assume a normal distribution. And we want to find or really estimate the probability he will finish on time. Okay, so let's just kind of wrap our brains around this. On average, 3 hours for homework. On average, 2.5 for the test. Those would add up to 5.5. So it looks like he should have a decent chance of finishing under 6 hours. The thing is, it doesn't say exactly 3 and 2.5. It is randomly distributed. We have this standard deviation here, so there are going to probably be some instances where he will not finish on time. So here's what we'll have to do first. We'll want to generate some random numbers first for homework. Now, as in the previous video, I'm going to generate 1,000 of them, which give us a reasonable estimation. If you did a much larger number, probably would get more accuracy, but it could slow down your the process considerably depending on your computer speed. So we'll just do 1,000. All right, so I want to click on my Data tab. And I will say this, on some computers, if your cursor was still on top of that homework you typed in there, you might have trouble pulling this up. So I'll always move it to an empty space. All right, data analysis, random number generation. Number of variables. That's essentially just going to be the number of columns, so it's going to be 1 here. Number of random numbers, that'll be the 1,000 random numbers we want to put underneath it there. Let's select normal, and let's put in the mean and the standard deviation. It is 3, and it's 0.3. Leave random seed blank, and for output range, just put it here in column H under homework. Let's click OK, see what happens. Okay, I like the looks of that. I know the mean's supposed to be 3, so sometimes I'm a little above 3, sometimes a bit below 3. Looks reasonable. And let's do the same process now for Joe's test time. Now the only difference, it's still normal. We just have a different mean and standard deviation, 2.5 and 5. So that will be easy enough. Oh. See, I tried to pull the data analysis, it didn't work. My cursor's still on the word test, so I have to move that. Random number generation. Still 1 column here, 1,000 of them, normal, 2.5, and 0.5. Okay, good. Let's move it over to the next column. There into, in my case, I2. And let's generate those. So now some are above 2.5, some are below 2.5. So we got that. So let's remind ourselves, what are we supposed to be doing? Well, it says find the probability he will finish on time. So as soon as he finishes his homework, he can move to his test. And we just need to make sure that the total of homework and test time will be within 6. So let's look at the first one here, 3.2, 2.3. Those add up to about 5.5. So that would definitely be good. Some of these probably won't be. So the easiest thing we could do would be to just create a sum column where we just go and add these two up and have a look at it. So in the first cell here, I'm going to use the sum command. You could just as easily click on one and then just put your plus sign in between them. But there, that'll add those up. 5.6, that's under 6 hours. That'll be nice. To do it for all 1,000 of them, click on the 5.6. Now, you should know this from the previous video, but I'll just stop and point out for a minute. when you generated your random numbers, you wouldn't get exactly the same thing I'm getting. So, you know, you're following the logic, but your numbers will be different. So whatever you have here for that number, I want to double click there on that little dot, and it will go and add up homework and test for each of these 1,000 rows here. So again, you should know that you probably see different things. So if we wanted to find the probability, I'll type that out. Let's find the probability that the sum is less than or equal to 6. Let's figure that out. Well, what we have to do is count how many of these sums are less than or equal to 6, and then we have to divide by the total. So I will do the count function, pick that, and I want to be, count if, I tricked myself there, always read down the list. We want to count to see how many of these sums are less than or equal to 6. So I can click on the J here, and it knows to ignore anything that has words in it. So I've got that. And then the criteria, which is less than or equal to 6, you just type that within quotation marks. Less than or equal to 6, end it with a quotation mark, and close the parentheses. I still have to divide, but let me just, while I'm at it, click enter. Now I got 810. You're viewing this, you probably didn't get exactly 810 because, you know, due to randomness, you had different numbers generated here. But my guess is you probably weren't terribly far from that either. So let's go back on that, up to the formula bar, and to change that into probability, let's divide by the total number of rows. Now we know it's 1,000, right? Because we did that specifically. But the nice thing of using count is you don't have to actually know how many rows of data you had. Now H, I, and J all have the same number of rows here, so it won't matter which one you click on to get the count. So notice I just said count the number of items in the sum column. And let's do that. And before it was 810. 810 out of 1,000 would be 0.81. So that is my estimate of the probability. Again, you probably would not get exactly 0.81. You'd be very unlikely to, but you probably got something not terribly far away from that. Okay, now let's have a little fun with number 2. Jolene is flying from Augusta to Detroit with a stop in Atlanta. Here's some of the details. She leaves Augusta at noon. She needs to land in Atlanta by 2 p.m. to catch her 2:30 p.m. flight to Detroit. Half an hour there? Well, you know how big Atlanta is. Then she needs to land in Detroit by 5 p.m. or she'll be late for her wedding to Joe, who fortunately did pass his quant class. So we have some flight times here, Augusta to Atlanta, then Atlanta to Detroit, and their normal distributions. So what's the probability she gets married on time? Now before you stop this video thinking, oh, this is just another example of the previous, it turns out to have a subtle twist to it, even though we'll kind of start it out the same in a similar way. So let's start out by generating random numbers that'll simulate both of these flights. You know, so instead of homework, I'm going to have Augusta to Atlanta. So let's do that. Normal distribution, easy to do. Random number generation. So Augusta to Atlanta, again, it's just this one column, so we want that one. Said let's do 1,000 for all these. Normal. What is it? It says it's 1.8, and it has a standard deviation of 0.25. we go. You know, we don't want to overwrite things, so let's select that range, put it right underneath the heading here. And there we are. Mean of 1.8. And let's proceed right away here and go and do the same sort of thing for the next leg of the flight, Atlanta. Atlanta to Detroit. Move off of that and do your random number generator. Only thing we have to change would be the mean, which for this next flight is 2.4. We'll change the standard deviation to that 0.5, and of course you don't want to overwrite it. So do that. There we go. Mean's higher, it's 2.4, so you do get some bigger numbers than you had for the previous. Now, that was fast and easy, but now we have to decide how to do the logic to calculate the probability that she makes it to Detroit on time, gets married on time. Well, you might figure that, let's see, she leaves Augusta at noon and she has to get to Detroit on 5. You might figure we could do it like the previous problem and just do a sum. But notice, that wouldn't work in the real world, because here Jolene has to get from Augusta to Atlanta by 2 p.m. or she's going to miss her flight. And if she misses her flight, it makes no difference how long the next flight makes. She's already out of luck. So let's look at the first row of data here. These have to be within 2 hours to be within luck. Well, it looks like often she is, but like look at mine here. I know your numbers are different, right? But somewhere along the way, you're going to find something that's bigger than 2. And that means, you know, that she's not going to make it to her next flight. She's going to miss her connection. It said she needs to land by 2 o'clock. So we really have 2 conditions here. First of all, this first flight has to be within 2 hours. And what about the next one? Well, it's a 2:30 flight, has to be in Detroit by 5, so this has to be within 2.5 hours, 2:30 to 5. Is it always within 2.5 hours? Look at your own data, but I certainly see sometimes mine are not. So here, adding them up isn't going to help us. We need to look at both conditions, within 2 hours for the first flight and within 2.5 hours for the second. So fortunately, we do have a variation on the COUNTIF function that allows us to check more than one thing. It's COUNTIFs, COUNTIFs. Let's do our equal sign and find it. So start typing. Okay, see how we found count? We know we have count. We have COUNTIF, and here, look, we have COUNTIFs. This will allow us to check as many things as we want. So the first thing we do is we select the criteria range. Well, let's look at that first flight. That'll be our criteria range. Look at column N. We do a comma, and then just like we did with the problem with Joe and his homework, we type in the criteria. Remember, we do that in quotation marks. So we'll do criteria, and we'll go, oh, she's got to make that first flight within 2 hours. So that would be less than or equal to 2. All right? So let's suppose she makes that. Then we want to look at the second flight. So I'll click on my column O here. I'll do a comma. And then the next criteria in quotation marks. And remember, that is the flight leaves at 2:30 for Detroit. She has to land by 5. That's within 2.5 hours. So less than or equal to 2.5. Quotation mark. And we only have these two conditions, so I stop. Imagine if I expanded this to, a third flight. No problem, right? We just have to have another column and continue that. So count ifs, as many things as you want to check. Well, while we're at it, let's divide by the count. Again, we happen to know that it's 1,000 for this, so we could just do divide by 1,000, but it's kind of nice doing it generically. Either of these columns has 1,000 numbers in them, so click on whichever one you want. Now let's see what that probability turns out to be. For me, I got 0.452. In preparation for this video, I had done it, and I got 0.437. You're undoubtedly getting something a little bit different. I'm sure you're not getting something like 0.7, though, you know? So simulation gives us an estimate. Now, if I had all of my viewers here in the classroom, I could have you all do it. And we could then take all of our answers and we could average those to even get a better answer. You know, so understand simulation has its limits. The way to get a more accurate estimation would be like instead of doing 1,000, doing like 10,000 or 100,000. I'm not actually sure what the limit is with Excel, but I know that even 10,000 can slow you down a bit. But it would be that, or keep doing this a number of times and average your answers. You know, so simulation's a fantastic tool to get reasonably accurate solutions. One thing I'll point out, the prerequisite for this class was statistics. You know, you probably used a TI-84 in statistics. These problems with sort of multi-stage things going on be very difficult to do by what you learned in statistics. So simulation just allows you to approximate more realistic sorts of problems. I hope you enjoyed these problems, and I'm going to sign out now.